So we have the client machine with an IP 192.168.0.2 with an operating system Ubuntu 24.04 LTS, which comes with the OpenVPN version 269 inbuilt. If you do not have the OpenVPN package available, you can directly download the same using the apt install OpenVPN command on Ubuntu operating system. We have the PfSense firewall WAN 1 with an IP 192.168.0.109, and we have the WAN 2 interface with an IP 14.140.40.109. PfSense firewall WAN 1 interface will listen for the OpenVPN connection, and we have the OpenVPN IP pool 2020/20/24 for the IP assignment when the client machine connects to the PfSense firewall and when they establish the OpenVPN tunnel. The client machine 192.168.0.2 will connect to the PfSense firewall, will initiate the OpenVPN connection onto the WAN interface 192.168.0.109. Once the OpenVPN tunnel is established, the PfSense firewall will assign an IP from the pool 2020/20/0/24, and post the assignment of the IP, the client machine 192.168.0.2 will be able to access the WAN 2 interface 14.140.40.109. So we will have the split tunneling configured in this particular OpenVPN configuration, so that the traffic towards 14.140.40.109 is only onboarded onto the OpenVPN tunnel, and rest of the traffic goes directly to the internet via the configured gateway on the client machine. Now let's try to move on to the configuration on the PfSense firewall. So this is the PfSense firewall running on 2.7.2 release, and we have the interfaces already configured. WAN 2 with an IP 14.140.40.109, WAN 1 with an IP 192.168.0.109. OpenVPN is hosted on WAN 1 on a standard OpenVPN port. Intention is to allow access to 14.140.40.109 through the OpenVPN tunnel. You will have to come to System, go to Package Manager, click on Available Package, and search for OpenVPN. You will see the package with the name OpenVPN Client Export. Try to install that. I'll show you the reason why you would need this particular package. Package is installed successfully, and you can check out the status of the package inside the installed packages. Next is the certificate generation. Click on certificate. You will have to create the certificate authority certificate. Let's try to add that. The descriptive name would be PfSense CA. Method is going to be internal certificate authority. Add this certificate authority to the operating system trust store. Let's try to check that option. Scroll down, internal certificate authority. You will have to enter the information about the key size. Key type is RSA. Size is 2048. Digest algorithm is SHA-256. Lifetime is going to be 3650. I'm keeping it default. Common name, let's try to name it as pfsense.sumit.com. Country code. Let's try to fill in all the required details here. Click on Save to generate the internal CA certificate. Now we have the CA certificate generated. Let's try to create the server certificate. Let's name it as OpenVPN Server. Inside the internal certificate, let's try to select the CA that we have generated in the first step. Key type RSA 2048, size, digest algorithm SHA-256, lifetime 3650. Let's try to keep this 365, 1 year. Common name is going to be openvpn.sumit.com. Here is the certificate attributes. Let's try to select the certificate type as server certificate, and alternative name we can try entering the IP address on the WAN 1 interface, which is 192.168.0.109. You can add multiple subject alternative names here by clicking on add SAN row. In my case, I can make this configuration work with the common name and with the IP address. Let's try to save this configuration. Configuration is saved. We have the CA certificate created and we have the internal certificate created with the help of the CA certificate. You can see the issuer name here and the certificate information. Next step is to create the user for the user authentication. When somebody tries to connect from the client machine, click on user manager, click on add. Let's try to create the user with the name test. Enter the password, confirm the password. We can skip the other settings, scroll down, click on certificate. And inside the certificate authority, you can select the same CA certificate. This is going to be the certificate for the user, which is test. RSA 2048-256, lifetime 365. Let's try to save this. So now we have the user created, test, and we have the user certificate generated as well. You can check out the status of the certificate inside the certificates. Seems like the certificate is not generated for this particular user. Let me try to add it again. Might have missed some information there. Common name is going to be test.sumit.com and it is going to be user certificate inside the certificate type. Instead of FQTN, we can try adding IP address, and we can add the actual IP address of the user. Now let's try to save and see. Now you can see the user certificate here inside this section. Save the setting, go to certificates to confirm. Now you can see we have the user certificate, we have the server certificate. Next, you will have to click on VPN and you will have to select the OpenVPN here. Click on add, enter the name. We will name it as OpenVPN Server. Server mode is going to be remote access, SSL/TLS plus user authentication. If you do not require user authentication, you can skip this option and go for remote access, SSL TLS or peer-to-peer SSL TLS. In my case, I would like the client machines to authenticate themselves. So I'll go with the last option, which is remote access SSL TLS user auth. Device mode is tunnel, layer 3 tunnel mode. Protocol is UDP by default. And interface is going to be WAN 1 because the WAN 1 interface is listening on port 1194, which is the standard OpenVPN port. I'm going to use the TLS configuration, TLS key, automatically generate the TLS key for authentication. Peer certificate authority is the PfSense CA certificate that we have generated. OCSP check is not required. Server certificate is the OpenVPN Server certificate that we have generated. DH parameter 2048 bit. ECDH curve default, data encryption algorithm, I'm going with the default configuration. Maybe I can remove that option. I'll go with AES 256 GCM, AES 128 GCM. We can try adding AES 256 CBC, and we can try adding AES 192 CBC, 128 CBC. That should be enough. Next option is the fallback data encryption algorithm, AES 256 CBC. I'm going to keep it default. Auth digest algorithm is SHA-256. Hardware crypto, no hardware crypto acceleration. Certificate depth. Let's go with do not check. If you are familiar with the PKI inside your network, then you can obviously go as per the configuration inside your network. For example, if you have 4 intermediate certificate authority, then you can go with the option 5. Strict user common name matching. I'll not enforce that. Client certificate key usage validation. Let's try to keep that enabled. Inside the tunnel settings, you will have to mention the scope 2020/20/24 in my case, which will be used for the IP address assignment for the client machines that connects to the PfSense firewall. The first IP in the scope will be used for the OpenVPN tunnel, and the subsequent IPs will be used for the client machines that gets connected to the PfSense firewall on WAN 1. IPv6 tunnel network is not there, so I'm going to keep it as blank. Redirect IPv4 gateway, do not want to do that. Inside the IPv4 local networks, you will have to specify the network that you're trying to access through the OpenVPN tunnel. In my case, it is going to be 14.140.40.109, which is the IP address configured on WAN 2. And this particular IP address is used for the management of the PfSense firewall. IPv6 local networks, I do not have any, so I'm going to keep it as blank. Concurrent connection, if you wish, you can update the number here. Allow compression, I'm going with the default settings. Coming down to client settings, dynamic. Well, we can have this particular checked. Allow connected client to retain their connection if their IP address changes. Settings for the ping for the liveliness check. If you wish to enforce the DNS settings, you can click on this and then provide the DNS default domain or DNS server enable. I do not wish to do that. I want the client machine to use their local DNS. And the gateway creation, I'll go with the IPv4 only since I do not have IPv6 configuration. Configuration looks okay. Now let's try to save the configuration. Configuration is saved. Now if you click on the client export, you will see the remote access server. You can select the one that we have created here inside the server, and if you scroll down, you will see the option to download the OpenVPN client application as well as the configuration file. This particular option, client export, is only available if you have the package installed that we have done in the first step. So if you go to the package manager, installed package, well, this is the package that allows you to export the OpenVPN application along with the configuration. Next, we will try to configure the rule on the firewall on WAN 1 to allow the OpenVPN traffic on WAN 1 port. Action is going to be pass WAN 1 UDP. Let's try to find the OpenVPN 1194, which is going to be the destination port. So now we have created the rule which states that the UDP traffic on port 1194 on WAN 1 is allowed. Apply the changes. You will have to create a rule on OpenVPN tunnel to allow the traffic for the WAN 2 IP 14.140.40.109. This particular rule will allow the access to the PfSense firewall using the WAN 2 IP address, which is 14.140.40.109. We will try to export the OpenVPN configuration. Go to OpenVPN and the last option that you see here, client export. After that, you should be able to select the OpenVPN profile that we have created. Hostname resolution, keep it to interface IP address. Verify server common name, automatic. Scroll down, and at the last section you will see OpenVPN client, which is where you will get the OpenVPN client application package and the OpenVPN configuration file. And in the OpenVPN client section you can download the configuration. For example, most client, if you click on that, will then download the configuration file. So this is my configuration file. I'll try to copy this to the Ubuntu machine. This is the Ubuntu machine and I have 2 sessions active. You can see here, this is the Ubuntu machine 2404.1 LTS. The OpenVPN package that comes in built in with this particular operating system 269. If you do not have, you can try to use the command. This will make sure you fetch the required package. As you can see, it updated the OpenVPN to 2612. The IP address configured on the NIC1, which is ENX0, is 192.168.0.2. We have already copied the OpenVPN configuration file. So this is the OpenVPN configuration file for the client machine. Another thing that you will have to do is to export the CA certificate so that the Ubuntu client machine can trust the server and the client certificate that we have generated in the configuration. Click on export CA. This will export the certificate. I have already copied the certificate and the configuration file with an extension OVPN. I'll share the link for this article in the description below, which has all the commands to import the certificate and the OpenVPN configuration. I'll try to show you the status of the certificate as of now using the curl command. You can see the status of the SSL certificate verify result here, which says it is self-signed certificate. Let me try to import the certificate and then we can try to check the status. Let's try to copy our CA certificate from the desktop to user local share CA certificate. Now we'll update the CA certificate store. Let's try to check the certificate status now. SSL certificate verify, okay. After that, you can use the CLI to connect to the OpenVPN server using the command sudo openvpn --config, and then you can specify the path to the configuration file. This is the file name. And then you can click enter. That will connect to the OpenVPN server, which is the PfSense firewall. Before that, let me try to show you the route. As of now, we have the default route pointing to the upstream gateway that allows the internet connectivity. Post this, you will have to enter the username, which is test in our case, and the password. This will initiate the OpenVPN traffic towards the PfSense firewall. PfSense firewall will assign an IP 20.20.20.2 from the scope that we have configured, and you can check the status here. Once the tunnel is in established state, you can check the routing table, and you can see here, because of the split tunneling configured, 14.140.40.109 is getting injected into the routing table, which says the gateway 2020.20.1 to be used for routing the traffic towards 14.140.40.109. 2020.20.1 is the IP address configured on the PfSense firewall for the tunnel interface created. If you check the NICs, you will see the TUN0 interface created once you establish the tunnel, and that will have the IP address assignment 2020.20.2. So this particular journal CTL for network manager will give you all the details about the connectivity, the flow of traffic, the adapter in use, and at the same time you can use the tail command and you can check the syslog. For example, let me quickly try to disconnect the tunnel. And now once I reconnect the tunnel, you should see all the related logs related to the OpenVPN. You can see here all the details regarding the OpenVPN, the interface associated, successful, and you can try to ping the remote IP 14.140.40.109. You should be able to ping that IP since the tunnel is active and you have the route injected. At the same time, you should be able to reach out to the internet. On the PfSense firewall, if you click on status OpenVPN, you should see the status of the OpenVPN, the client connection count 1, common name test.summit.com, real IP 192.168.0.2, virtual IP 20.20.20.2, last change, byte sent, byte received, cipher in use, and you can check out the routing table information as well. Common name test.summit.com, real IP address 192.168.0.2, target network 20.20.20.2. This is the interface on the PfSense firewall OpenVPN 1, which will have the first IP address 20.20.20.1 from the IP pool that we have configured. So the first IP will be configured and will be used for the OpenVPN tunnel interface on the PfSense firewall, and the subsequent IPs will be used for the client machine as it initiates the connection. In the next section, I'll show you how to initiate the connection from the network UI. So this is the Ubuntu machine. I've taken the RDP, go to the network section, and here you will see the option VPN. I have already imported one profile, so we'll ignore that. And if you click on plus sign, you should see the option for import file. You can click on import file, and then you can import the file and you can upload it. But I would not recommend you to use this option of importing, because I've seen a lot of issues when you try to import the file directly using the network UI. So instead of that, I would recommend you to use the CLI to import the configuration file onto the network manager. And to do so, you can use the command, which is sudo nm cli connection import type OpenVPN and the file name. Let me quickly try to import the file. This is the OpenVPN configuration file that we have downloaded. Let me try to use the same. Once that is imported, will show up on your network manager. Let's go back to the UI. This is the OpenVPN configuration that we have imported. Click on settings, click on identity. If you see here the username is not imported, you will have to enter it manually. So in our case, the username is test and the password is password. Let's try to rename it as OpenVPN. If you want, you can click on advanced setting to check out the advanced settings, example the cipher, HMAC authentication, TLS authentication, proxy, etc. In our case, that is not required. Click on apply. So that will make sure we have the profile in place inside the network manager. And you can use the option to connect. For example, you can see here we already have the OpenVPN tunnel established. Ping is going on. We have the OpenVPN tunnel in established state. Let me try to disconnect that. Post disconnection, ping for 14.140.40.109 will fail. And the route for 14.140.40.109 will be withdrawn from the routing table. Another verification what we can do here is, once we have the tunnel active, we can take a capture on the PfSense firewall tunnel interface, which is OVPNS1, and this is the virtual IP address assigned to the OpenVPN client, which in our case is Ubuntu 24.04. Let's try to initiate some traffic from the Ubuntu machine. And you should see the traffic onto the tunnel interface on the PfSense. That's all in this video. Please do not forget to subscribe to the channel and hit the like button. See you in the next video.